Okay, so this next section is talking about the real zeros of a polynomial function. Okay, so again, let's dissect what the title is saying. Okay, so real, right? Real numbers. It's talking about real numbers. There. All right, so that means we're not dealing with complex, no complex, or imaginary numbers, no i's. Okay, all right. Now, zeros here is referring to, and I'll talk about or distinguish between these in a second, um, x-intercepts, roots, factors. Okay. And then the polynomial is what we've been working with throughout the semester. So like x squared plus 6x plus 9, that's a polynomial. X cubed plus x squared plus 1 is a polynomial. Okay. All right, x to the fifth plus x to the fourth plus 7 is a polynomial. So all of these are different types of polynomial. Now, what is not a polynomial is when the power is no longer an integer. So for example, x raised to the square root of 3 plus x squared plus 1. So this is not a polynomial, okay? Or something like 1 over x to the fourth plus x to the fifth plus 5, right? Again, this is also not a polynomial, okay? So anytime you mess with the power, right, then it's no longer a polynomial. And then the function here again means it passes the vertical line test. Okay. All right. So that's what this title is referring to. Okay. So let's talk a little about the difference between a factor and a root, because a lot of times they interchange them and there is actually a difference. So if we have the trinomial x squared minus 7x plus 12, and I factor them, I get x minus 4 and x minus 3, okay? So these are called your factors, right? These are your factors. Now, when um, when I set them to 0, okay? So when I set this same trinomial to 0, so x squared minus 7x plus 12, and I set that equal to 0. So when we solve this, again, we get x minus 4, x minus 3 equals 0. So when we solve this, okay, we get x equals 4 and x equals 3. And this is what? These are your x-intercepts, okay? They're also called zeros. Right? So the x-intercepts, when you solve them, all right, are again, x-intercepts are zeros. Okay. And they're also called roots. Okay. So these are all the same thing. Okay. But before you solve them, when they're in this form here on the left, these are factors. Okay. That's the difference between a factor and a root. Okay. So just to make sure we understand this, so factor form, and then um, roots, okay, or zeros. Okay, so if I have, again, x minus 4 and x minus 3, when I solve for x, the roots are going to be 4 and 3, okay? If I have x minus 7 and x minus 5, what's going to be the roots there? exactly, right? It's going to be 7 and 5. But if I have x plus 6 and x minus 2, what's going to be the roots there? Exactly, right? It's going to be -6 and 2. Okay? Now, if I want to, let's say I have my root. Okay? I have my root. They gave me the roots of 4 and 3, and I need it in factored form, then I would write it as x minus 4 and x minus 3. Okay? Again, this one would be, if I had the roots of -6 and 2, in factor form will be x plus 6 and then x minus 2. Does that make sense? Okay? So again, need to understand the difference between the two, right? Distinguish them. All right, and then the last part here is what happens when we divide just by a term. So let's say we had, x to the 5th divided by x to the, just regular x to the first power, right? That means then we're going to subtract the power, 5 minus 1 will give us x to the 4th, or if I wrote this out, right, I'm going to cancel one of the x's and I have, oops, I have x to the 4th left, okay? So again, if I do that again, so if I have x to the 9th divided by x, that will give me x to the 8th, correct? All right. So when I divide by just a regular x term, it reduces that power by 1. That makes sense? All right. So again, keep this all in mind as we do the next, or as we do the problem. Okay. In fact, there's one more I need to just talk about here. Okay, and that is synthetic division. All right. Supposedly you guys should have learned this in the previous class. Synthetic. But we're going to need all of this information to do the problem. Synthetic. Okay, let's see there. Synthetic division. So let's say they say that x plus 3 is a factor of this polynomial. So it's 2x to the 5th plus 5x to the 4th minus 2x to the 3rd plus 2x squared minus 2x plus 3, right? So this polynomial here. Okay, why is it a polynomial? Because if you look at the powers, they're all integers. They're not some irrational square root or anything like that. They're all integers. Okay, so how do we do synthetic division? So to rejog your memory, all right, so we draw like a part of a box, okay? And then this row, we're going to put the coefficients, okay? Coefficients of the polynomial, all right? And then this row here, we're going to multiply and divide, okay? Multiply and divide, sorry. Multiply and add. Okay. And now here we're going to put the root. Okay. All right. So let's do this. Okay, so in this row, I'm going to put the coefficients of the polynomial. So the polynomial is this whole expression here. So that's just going to be 2. Let me use a different color here. Okay, so I'm going to have 2, 5, -2, 2, -2, and +3. Okay, so we have 2, 5, -2, 2, -2, and +3. Okay. All right. And then I'm going to put the root. So remember, x plus 3 is a factor. If I want the root, I have to equal it to 0 and solve for x. So in this case, when I do that, my root will be -3. And I'm trying to see whether this root, okay, is a factor of this. Okay. How do I do that? Well, we use synthetic division. So once we list our coefficient, what we're going to do next is we're going to take that 2 and bring it down. Okay. And then we're going to multiply. So -3 times 2, that's going to be -6 here. So we're going to put that number there. All right. And then we're going to subtract again. Okay, so -3 times, I'm sorry, we're going to add, not subtract. -3 times 2 is going to be -6. Then we add this, what gives us a -1, right? Because again, this is multiply and add. All right, then we're going to do is -3 times -1. We're going to put this, our result here, that's going to be a +3, and then we add. Okay, so -2 plus 3, that's going to give us a +1. -3 times 1 is going to give us a -3. Then we add again. So 2 plus -3 is -1. -3 times -1 is going to give me a +3. So we add -2 plus 3. It's going to give me a +1. All right. And then -3 times 1 is going to give me a -3. And then we add. So that's going to give us a remainder of 0. Okay. Or a result of 0, I should say. Okay, so what does this mean? Well, this is what we want. We want the result to be 0 at the end. So we want the result to be 0 at the end. Okay, so if it is not a 0, then it is not a root. Okay, all right. So if we had like a number here, like a 1, 3, 5, doesn't matter. Okay, if it's not 0, then it's not a root. Okay, now remember I mentioned that when we divide by just a regular x, okay, that reduces the power by 1. So if we were to write this back in factored form, or somewhat in similar to a factored form, -3 will give us, let me use will give us x plus 3, okay? And then these here, these numbers here are going to be the coefficients of our new polynomial, okay? Because we divided, this is basically division, right? We took this long polynomial and divided by x plus 3. That's what we did. We put it down here, okay? And so this is a shortcut to that. But it only works when your factor is raised to the power of 1. Doesn't work in any other way. Okay, but since we can use it, let's use it. So this becomes, so we had a power of 5. So now this will be 2x to the 4th, it reduces by 1, minus x to the 3rd plus x squared minus x plus 1. Okay, so we have a factor of x plus 3 and then this polynomial here. Okay. There is another step we're going to do, but we won't do that until our next example. Okay, so we want to find the zeros. So we have, say, we have this function, f of x is equal to x cubed plus 2x squared minus 5x minus 6. Okay. All right. So how do we do this? Well, what we need to do is step number 1 is we need to list our possible roots. Okay, so list our possible roots. Okay, so what we do is we take the factors of the last number and then we're going to divide that by the factors of the first number. Okay, So what do I mean by last and first? So this number here, this is your last number. And then the number in front here, that will be your first number. Okay. So the factors of the last number, we have 6. Okay. So that'll be 1, 6, 2, and 3. But we also have to consider the negatives. So this will be plus or minus 1, plus or minus 2, plus or minus 3, and then plus or minus 6. Okay, so those are the factors of the last number. And then for 1, well, that's easy. That's going to be plus or minus 1. Well, when we divide this, we actually spit out whatever is in the numerator. Okay, so plus, I mean, that's not always the case, but in this case, that's what we get. So plus or minus 1, plus minus 2, plus or minus 3, plus or minus 6. Okay, so those are going to be our possible roots. So that means we have we have 8 possibility, right? So total possible, we have 8 because 2, 4, 6, 8. But the actual, right? The actual roots, how many roots should we have here? Well, it's going to be 3, right? 3 is the highest power here. So that means we should have 3 answers, 3 roots. Okay. Sometimes they're imaginary, but that's not what we're looking for, but it might be. So the actual roots is 3. Okay. All right, so we're going to do long division to do this. So we're going to take, again, we're going to draw. So step 2, we're going to do long division. I'm sorry, not long division, synthetic division. Synthetic division. Okay, so we're going to draw our box. All right. And then we're going to list the coefficients of that polynomial. So 1, 2, -5, and -6. Okay. All right, so let me do, so again, I like to pick numbers that are close, the lower numbers first, then go up. So let's say we pick 1, all right? So if I go pick 1, let's see if that's going to work out. Well, I'm going to bring this one down, okay, and then going to multiply. 1 times 1, that's going to give me 1, then I'm going to add. 2 plus 1 is 3. 1 plus 1 times 3 is going to give me 3, then add these guys, gives me 2, -2. Then 1 times 3, sorry, 1 times -2 is going to give me -2, okay, and then I add them. So that's going to give me the answer of -8, okay? So is 1 a root, a factor? I'm sorry, a root of this polynomial? No, because it's not 0, right? So in this case, no, not a root, okay? Because this is not equal to 0, okay? So then we move on to the next one. So we do it again, okay? So normally what I would do is I would go 1, -1, 2, -2, something like that, right? But we're running out of time here, so let's pick another one. So let's say we have 2. Okay, but normally I do 1, -1, 2, -2. All right, so go ahead and try this here. We have a couple minutes to see if you get this one here. Okay, so we have, again, we're going to list the coefficients. We have 1, 2, -5, and -6. Okay, the first term we bring it down. So, and then we multiply the root. 2 times 1, that's going to give us the 2, right? Then we're going to add. So then 2 plus 2 will give us 4. 2 times 4 is going to give us 8. Then we add. -5 plus 8 is going to give us a positive 3. Then 2 times 3 is going to give us a 6. Then we add, okay? -6 plus 6 is 0. Check. That is what we want, right? The result there is 0. So what does that mean? That means 2 is a root or a 0 of this polynomial, right? And we found 1. How many do we need? We need 3 of them, okay? Once you find 1, it's easy to find the other ones. I'll tell you what I mean by that. So let's write this in factored form. Okay, so remember the root is 2 in factored form, that's going to be x minus 2, right? And these numbers here at the end are going to be the coefficients of our new polynomial. So that's going to be 1x squared plus 4x plus 3, right? Those are the coefficients of our new polynomial. Well, we can factor this, okay? So this can be factored to x plus 3 and x plus 1, and then we have x minus 2, okay? So that's what we have here. So then, again, we want the roots. So we need to set these to 0. So we're going to have x minus 2 equals 0, and x plus 3 is equal to 0, and x plus 1 is equal to 0. Okay? So again, we'll have x equals 2 when we solve for x, subtract 3 on both sides, so we get x equals negative 3. And then the next one, we get x is equal to negative 1. Right? So those are our remaining roots. We found them. We found 2 as the first one, and we found the other ones by factoring them. Okay, so that's what we want. We wanted 3, and that's what we got. Okay, so these are the zeros or the roots of this polynomial. Okay, I want to do one more example here. Okay, of finding the zeros or roots of this polynomial. So again, step number 1 is we want to find the possible roots or list the possible roots. Okay, so again, you're going to take the last number and then divide it by the first number, or I should say the factors of the last number divided by the factors of the first number. So in this case, our factors for 20 is going to be plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and then plus or minus 20 divided by plus or minus 1. Okay? So when we divide this, we actually get the same thing as the one on top. Okay? So we'll just get the same result when we divide this by plus or minus 1. So that means then our possible roots are 2, 4, 6, 8, 10, 12. We have 12 possible roots, but in reality, we only want 1. 3, right? We have a power of 3, so we only want 3 of them. So we need to use long division. So step number 2. Okay, I keep saying long division, but it's synthetic division. We're going to use synthetic division to find that. Okay, so we're going to list our coefficients. Okay, so I'm going to use a different color here. Okay, so we have 1, 8, 11, and minus 20. Okay. So, like I said, I like to use the lower numbers first. 1, -1, 2, -2, okay? Because most of the time, if I find those numbers or find those roots, then I can find the other ones. So I'm going to use, in this case, 1. All right, so I'll use that. So I bring that 1 down, and I multiply. So 1 times 1 is going to give us 1. Then we add. 8 plus 1 is 9. 1 times 9 is 9. Then we add again. 11 plus 9 is 20. 1 times 20 is going to give me 20. So we add again. That gives us 0. Okay. So that's what we want. We want the result to be 0. Okay. So what does this mean? That means 1 is a root. Okay. Of this polynomial over 0. Okay. So let's go ahead and write this now in factored form. So we're going to have x minus 1 times, again, these are going to be the coefficients of our new polynomial. So that'll be x squared, oops, plus 9x plus 20. Okay, and then I'm going to factor this. So we have x minus 1, and that'll be x plus 5, and then x plus 4 equals 0. Okay, so when we solve for x, we're going to get x is equal to x is equal to 1, -5, and -4, right? So these are our roots or in this case, zeros.